This is my South Bend 9-inch metal lathe, and in my last video, I made this stand for it. It's using 4 of my modular cabinets, and it has a steel pan on the top of it that is allegedly oil tight, so that pan will catch all of the oil drippings and the chips. Underneath here is a bunch of layers of MDF, so it has a lot of mass that will hopefully be good for vibration damping. And on the front, I welded on this switch bar. So this is a piece of angle iron that is attached to some hinges. So I'll be able to pull that out or push it in to turn it on or turn it off. And in this video, I'm gonna finish making this switch work and hopefully get the lathe actually running. I want to address right up front that I'm actually not gonna be making this motor reversible for now. So the lathe is only gonna run in forward at the end of this video. This motor is something kind of weird that I don't quite understand. It's an instant reverse motor, but it's missing some parts. It's missing the reversing relay. Someone has bypassed that. I'm sure I could probably figure it out, but for right now, I just want this lathe to work. That's my priority. So I'm just not gonna deal with reverse until later. So the first thing I want to do is make this power switch have a detent so that when I pull it out, it will snap back to the center, and when I push it in, it will snap back to the center. I'm filming this out of order, so that's actually already done, and I can show you how it works. If I pull it out, it doesn't have very much travel, so it might be kind of hard to see, but that will be turning it on and turning it off. So I'll start by showing you how I made the detent to make it behave like that, and then we'll move on to the wiring. And I'll show you a couple of my prototypes that didn't make the cut so that you can see my design process. So this is my most elaborate prototype so far. I have this V-block with a bearing rolling into the V. On the back side, there's a spring that pulls that bearing into the V. The bearing is on this little arm that goes up to here, this pivot point, and then this arm connects it to the power switch itself. So if I pull on the power switch, the bearing rolls down that V and stretches the spring, and if I push on the power switch, it pulls it up the V and also stretches the spring. So this gives it a fairly good positive center, but I don't quite like how it feels yet. It moves too hard. It's not that the spring is too strong, it's that there's too much friction in everything. So I need to design something with less friction. This is my next attempt, and this works so much better. This thing is one of these, like a closet door latch. It's just a spring-loaded ball. So I just have that pushing against the bottom of this stick that's attached to the power switch, and then I have a spring pushing down on the top of it. So if I pull out on the power switch, it compresses that ball detent, and if I push in on the power switch, well, I'm gonna want a limit to keep it from going so far, but you get the idea. It's important that I'm using one of these and not just a spring on the bottom, because this has a positive stop on the upper limit. If I was using a spring here instead, there would be no specific center point. It would just be kind of mushy all the way. This gives me that nice sharp center point. I just realized that it would make more sense to turn this upside down. So I'm noticing that with the spring, if I pull the switch out and then I sort of slip my finger off of it, it flutters back and forth a little bit. So I think it's actually enough that if I were to turn it on and then let go, that could be enough to turn it back off immediately. I'm gonna record that in slow-mo and see if it's actually compressing the ball all the way. So it looks like it is compressing the ball all of the way. So I'm gonna try replacing the spring with just a second ball detent. That will also give it more of a consistent feel between pulling and pushing. So there's definitely less recoil now, but it would still be a problem. However, I think the mass of this clamp being so far out here, it has quite a bit of inertia, and that's what's causing that. So if I get rid of this clamp, it'll have a much smaller moment of inertia. So I decided to just continue with the project, assuming that removing the clamp would fix that. I'll use this piece of steel square tubing to push on the ball. I'm using square tubing because it's steel so that I can weld it to the power switch, and it's pretty strong but lightweight, so it won't add too much to the moment of inertia. All right, that's a good length. I just need to cut off the top here. I tightened one of the bolts on this, so this is locked in place with it flush to the front of this. And now I'm just going to hold this in place with my hand and tack it on. So that's the top detent finished. Now I'm going to glue up this block of wood and shape it a little bit to hold the bottom detent. This whole block will go right in here like so. Currently the ball detents are a bit too far apart, so the square tube is able to kind of rattle between them. So I'm gonna just trim off the top of this until that's tight. I don't wanna go too far past where it's tight because I don't want it to actually be compressing these, or that's gonna make it have sort of a softer spot in the middle. Okay, now that's tight. I will put 2 more screws up here, and these are gonna go really deep into the MDF, so they're the ones that are gonna really be holding it, but I can't put them in until I take the power switch off, which I'm gonna do soon to paint it anyway. I 3D printed this little box. It has a channel on the backside for bringing the wire into the box, and it has holes here for mounting 2 micro switches. This is going to get screwed on right here, and then this little L-shaped piece of 1/4-inch rod will go up here. It's going to be welded onto this piece. It will stick into the box. Here it is with the 2 micro switches, so you can see how this is going to be able to click the micro switches when I push or pull on the switch. Now you'll notice in the 3D print right here there's a hole, and that is there just for welding this into place. So I've cut this L-shaped piece a little bit too long right now so that it can go into that hole. So now I can go ahead and mount this and weld it on here, and then after welding it on, I'll cut off the part that is in that hole so it will be able to move freely again. And that's how I'm going to ensure that this is in the perfect place. I'm going to temporarily mount this right now just to weld that stick on, and then we'll take this back off. So now I can put this stick in the hole that I printed, and now I can tack that on right there. Before I disassemble anything, I'll mark where this came to so that I can cut it off and be sure that it won't stick into that hole after cutting it off. I'm tempted to weld more on this to complete the weld all the way around, but this is more than strong enough to click a micro switch, and if I weld more on this, I risk warping it, which would change the position of this and make it click the micro switch at the wrong time. I printed this channel into the backside for the wire, so I can feed the wire through this hole and then press it into the channel. This will also act as a strain relief. I'll be using the green wire as a common, so it needs to go to both of the micro switches. So I trimmed a little bit of the wire off of both of these so that I can fit them both in one connector. I know this isn't the right way to do things, but this only draws 35 milliamps, so I'm not too worried about it. Since these 2 insulations don't fit into the barrel, I'm going to put a piece of heat shrink over them. And then with another connector on the other end of the little jumper wire, that's how I get the one common wire to connect to both microswitches. Before I screw this one down, I need to screw this back into the box because I need to be able to access the screw hole that's under this switch. When I made the MDF base for this table, I left a channel through the middle of it specifically for this wire. And now I can screw the other microswitch in place. I stuck a piece of wire insulation between the two microswitches while putting this bar in place, just to hold them apart so that I wouldn't accidentally break them. So here I'm testing to make sure that it doesn't hit the microswitches when they're all the way apart, which will ensure that I can't break them by pushing the switch too far. And there it works. The first time I printed this box, I put the holes for the microswitches in the wrong location. So here I'm using that failed print as a template for making the cover. So I need to cut out a notch here for the stick. I'm going to use my failed print and use this guide hole as a drill guide. I'll start with it offset a 1/4 inch this way and drill a hole, and then offset it a 1/4 inch this way and drill a hole. This cover plate has slots for the top screws because at this point those top screws are not accessible. Okay, I think it's time I show you how this switch is going to work. So what we've finished so far is this part. This represents the table, so this is where the wiring goes through the table, and all of this is going to be at the back. These are our two micro switches. This is a contactor, and the contactor is what's going to actually be turning the motor on and off. This is the plug, the power source. So I'm switching both the hot and neutral for this motor, which is not really necessary since it's 120 volt, but I have 3 poles on the contactor, so there's no reason not to. I'm running hot through both of the other poles of the contactor, one of them to the motor, and the other goes out to the stop switch. I'm also running hot out to the start switch. So the start switch is always powered directly from the plug, and the stop switch is only powered when the motor is on. So the way this works, when the contactor is open, there is no power on this blue line. So the stop switch does not have power, only the start switch does. The start switch is normally open. So if I momentarily click the start switch, that sends power back down this blue dashed line, which powers the coil on the contactor and closes the contactor. Now, as soon as the contactor is closed, we have power flowing down this solid blue line through the stop switch and back to the coil. So it will stay closed. But if I momentarily click the stop switch, that opens this. It breaks that circuit, so the contactor opens. One of the big advantages of this type of switch is that if you have a power outage while it's running, the contactor opens and you're going to have to hit the start switch again to restart it. So you'd never have an unexpected restart. So it's a good safety feature. Also, you know how you can get one of these switches stuck in the middle? And that seems kind of sketchy because it's pretty easy to accidentally tap it and turn it back on. I don't want that for my lathe because I don't want to ever accidentally only half turn it off and then have it turn back on when I have the key in the chuck, for example. This switch design seems like it basically eliminates that because if the lathe has stopped, I am going to have to press the start switch again in order for it to restart. So there's no chance of an accidental restart. I also want this design to be as future-proof as possible because I put a lot of work into this part, which is just this part. This all is fairly simple. It takes up more space on the whiteboard, but it's actually much simpler than this. I can very easily replace this in the future. For example, if I want to put a VFD on this lathe, I would like this to still be able to control that VFD, which would replace all of this. I think that this gives me some more versatility by just having 2 separate micro switches, a separate start and stop input. I think it's a bit more versatile than just an on-off. I could even do something like make it computer controlled so that pressing it again after it's already off would switch the direction, or maybe pressing and holding would switch the direction. And that's only possible if I have two separate inputs. This is a bit sketchy right now, but I just connected up the wires to the contactor. So you'll see that these two poles are still available. So that will be what the motor wiring is running through. All of this other wiring will just use the one pole. So if I plug this in and push and pull this, it should operate the contactor. It takes only a very brief moment of pulling or pushing on this to turn it on or off. So if I just kind of whack the back side of it, that's enough, it turns on and stays on. And if I just slap the front of it, that's enough that it turns off and stays off. Now I'm moving on to making the junction box that goes at the back of the lathe where the contactor will live. The lathe uses very little power, so I'm also putting an outlet in this box that can easily run on the same cord as the lathe, and this will be useful for something like a light. Drilling out spots for a couple of strain reliefs on the other end. This is 22 gauge metal, and I'm just using a couple pieces of square bar as clamp jaws to basically make a temporary break. It actually worked quite well. I'm very happy with how nice this came out. Then just cutting a back wall for the box. And then just marking where the holes for the contactor need to go and drilling those out before I weld the box together. And I am so happy with how this box turned out. It was a fair amount of work, but not that bad, and it looks really cool. I'm sure you're observing that this contactor is huge. It's definitely overkill. It can handle at least 5 times as many amps as the motor draws, but it's something I already had lying around, so I might as well use it. So the other end of this wire is already wired up to the motor, and I'm just gonna put the box under here where it goes and get an idea of how far I want this wire to go in. I want it to come around this chamfered corner so that this can go all the way in a corner, and I might as well just go ahead and tighten this clamp up. I'm wiring the ground from the motor and ground from the power cord both onto this screw, which will also ground the enclosure. These two wires are the hot and neutral from the motor. And these two are the hot and neutral coming in from the power cord. I looped both of them around these screw terminals so that I can connect them to more things. The neutral needs to connect here for the motor. It also needs to connect here on this outlet, and then it also needs to connect to the coil of the contactor. So I put these forks on this one, and I'm going to run both of those to here. And then I can run this one wire back to the coil here. This one's kind of going through quite a few stages, so I wouldn't want to run anything super high load on this, but the contactor is only a few milliamps, so it's fine. I'll use the same kind of fork connector for the hot side of this outlet. I did as much as I could up here where it was comfortable and well lit, but now I have to do the rest down here because I have to hook up this wire, which is fixed on that end. This, of course, is the wire coming in from the microswitches. This is the common wire coming back from the 2 microswitches, so it goes to the contact coil. It's represented by the dotted blue line on my schematic. And the black wire coming from the microswitches is supposed to be the switched hot, the hot that runs through the contactor. This will be where the power flows to keep the contactor coil energized as long as the lathe is on. So this is our incoming hot, and it loops around this contactor terminal, which supplies power to the motor. And then I'm going to connect this to 3 other wires. One of them supplies the other contactor terminal for the power to the microswitches at the front. One of them supplies the outlet. One of them supplies constant hot to the other microswitch at the front, because I need both a switched hot and a constant hot at the front. Pulling on each of the individual wires to be sure they're all secure, and we should be good. I had an extra piece of green wire, so I'm going to put an extra ground wire from this screw where all the grounds go up to one of the motor bolts on the bottom of the pan, which will give me a really good ground connection to the pan. In theory, this ground connection is redundant because the motor is already grounded, but I don't have any ground running up to the power switch, so I want to be extra sure. So this is connected directly to the power switch through the pan. This ensures that the power switch is grounded. So in theory, everything is done and the lathe should run, finally, for the first time in a couple years. Before I tuck this up underneath, I'm going to give it a test. It works! So now I just need to screw this enclosure to the bottom of the table, making sure I'm not pinching any wires anywhere. I forgot to check if the outlet works before putting it together, so let's check that. And that's it, it's done. It's gonna be really nice having this power switch running all the way across, because sometimes I'm over here, drilling with the tailstock or something, and I wanna have a power switch right here where I can easily turn it off. But then there's other times that I'm over here, maybe working on the back side of a flange or something, and I wanna have the power switch over here. So this is gonna be so nice. All right, I hope you enjoyed that and maybe learned something. Thanks for watching.